Hey guys, and welcome to the video. In this session, we're going to be doing a mock system design interview with a software engineer from Airbnb. The given questions apparently pretty common, and at the end, Vlad gives some feedback as well as a few tips for performing well on these SDI interviews. So with that, let's go ahead and get started.
So let's try to do this. Um, when you're using Uber, you can basically see all the cars on the map and
Yep.
how they move around. And that feature can be useful for other things too, right? Not just Uber, but any kind of like movements on a map. But let's keep this scenario in mind. Let's try to design a service to power this.
Okay, sure. So just to make sure that I get this, design, a multi-location uh, tracker on map.
Mhm.
Uh,
Yep, perfect.
so I'm only focusing on, just the portion that returns locations, right? There's no next step that would be matching people or anything like that.
Yeah.
Okay, only focuses on finding and displaying multiple users across the map. You can assume that the people are moving or not moving,
hmm
and of course, we'd want this to be near you. I'm assuming, right? Like it's only within some set, 2 by 2 kilometer
Uh,
zone or something like that.
the area that I'm interested in is not going to be huge,
Right.
but I should be able to move this map. So if I want to look at a different county or even at a different state, that shouldn't be a problem.
Oh, so you should be able to look at areas that are not local to you. Got
Yeah,
it.
definitely.
We'd want location tracking to be local to some set location, which can be anywhere.
Yeah, so I should be able to define
Where you're
where
searching.
what I'm looking at. Yeah, and
Cool.
kind of like to be able to also zoom in and zoom out a little bit,
Right.
but we can keep that within reasonable um,
Okay.
boundaries.
Cool. So I think for the actual things you can do on the map, that seems to be about it, right? Like you obviously don't care about being able to click on any of the cars or anything like that, or what it looks like. Let's
No,
just
this
pretend
is
that they're the thing we care about is dots, right? Not anything like orientation or anything like that, or
yeah,
where
yeah,
they're heading. So
yeah.
um,
We will have a lot of dots and a lot of viewers.
right. So
I
in
can
that
tell you that.
case, do we ever care about filtering out some of the dots in case there's too many? Like if there's 100 dots in a 2 by 2 kilometer space, maybe you don't want to show all of them, right? Or do we?
We can worry about this later. Yeah, it's probably a good idea to filter some out, but
Okay.
how we're gonna filter it, we can discuss that later.
Filter if too many dots. Cool. So all
Let's
right.
let's uh,
Let's.
let's say it's not a primary focus, but let's say we can design something that where somewhere you can plug in your custom filtering logic. Let's
Right.
make this kind of like a framework that anyone can use for anything,
Right.
and they can plug in things here and there, but it's not the primary focus right now.
Sure. So one thing to think of is how we're actually gonna, display all of the data on maps, right? So you'd obviously want
Mhm.
to separate all of your people into multiple zones. So realistically, you'd have to split up the grid into, let's say, 2 by 2 squares or hexagons, right? In order to actually contain all of the data that you could have for cars, because there's no way you can fit all of the location data for the entire world on a single machine, right? You
Mhm.
should split the world into multiple squares slash hexagons, um, maybe 2 km by 2 km, and for the actual, say, drivers sending out their data, I imagine that this is something that you'd want to have set as almost a poll, right? In the sense that whenever a driver is online, they should be sending us information to us.
Yeah.
They should be sending information to us about where they are right now.
Yeah, this is real life, real time tracking.
Drivers should be sending actual data about where they are. Periodically. And one thing to note is that GPS services aren't, super accurate, right? So what we'll actually get is a bunch of really, strange looking lines. Let's say it's like, this is an actual street. We'll maybe get like, positions like this, right? Even though they're all in the same lane. Let's say this is all one road. It's going to be kind of fuzzy data, right? So would get fuzzy data, some work done to, make it simple, in the sense that it would show that they're just, moving down a single line, right? Instead of all these weird different lines.
Yeah, it would be nice if the car wouldn't jump from here to there.
Yeah.
If it would be, yeah.
So, if the actual driver is sending out their periodic data, then we should, we just get it as some latitude, longitude, and let's say that we clean it and then we filter. Afterwards, how does this work out for, actually showing the locations to a user, right? So if they have their 2x2 block and they want to find all of the cars that are near them, the simplest thing would be to, of course, just show everybody within their block, right? But if they are on the, let's say you have, let's say this is our world, right? Let me just copy this. So if this is our world arena,
okay, let's make it simpler. Let's use these shapes. How about
yeah,
something like this?
Yeah.
I mean, you can model it.
Yeah. So let's say that they're right in the square middle of one of these blocks, right? It's really simple to figure out what cars might be near them, in the sense that we could just show them their block, right? But potentially, they're on a different point. Let's say that the user is right in the middle of, say, 4 of these, right? And that's their location. In that case, you would need to show a separate, radius.
So I'd be interested in something like, well, depending on what I'm scrolling, I'll potentially be interested in something like this.
Yeah.
Let me clear the.
Yeah.
This could happen, yes.
Yeah. So I think that even if you have this situation, it's pretty okay, and you should be able to get, all of the data from those quadrants, or from those squares, and then sort of do a filter which says within this radius, right, of the user.
Yep.
So I think as long as we have this, square or hexagon set up, it's pretty okay for.
Let's define our API.
Yeah, sure. So for the API,
You may want to leave the thing there, the drawing.
Sure.
Yeah.
So there's a couple of things that we had, right? So you have the driver, which should be able to send location, which is going to take a long, and I guess the time we don't really have to care about, right? And then I guess who they are, user driver data, and then the rider is going to search location, or search location, which is going to take a location, as well as, I guess you could have a radius, right? because they
So
should be able to zoom in
what's
and
what's
out.
a location?
Yeah, so this is would be a lat long, which by default should be their lat long, but if they decide to, search somewhere else, we should also be able to do
Mhm.
that, right? So let's just say that's lat long instead of radius, or instead of just location. Um, is radius the only other thing you care about?
So radius basically implies that my search area is a square or a
A circle.
circle,
Yeah.
either a circle or a square.
Right.
That's
So
not always the case. It's most likely a rectangle.
right, because of the screen. So what I was thinking is that a lot of the time you would actually have a search radius that's slightly larger than the area that you can fit into screen. Almost always, even though you're going to be, spending a bit extra compute to get that, uh, realistically you'd want to set it to being the largest that the user could zoom out into, right? Maybe.
Okay.
That's not true. Uh, I was thinking you'd always have it to the largest that they could zoom out to, and then they would, when you zoom out, there's no reason to have to query the backend again, right? But that's kind of a waste if
Well, let's
majority of the
see.
time users use a
How
default view.
how often do you query the backend?
So there's the initial call, and then when you update, right? Um, yeah.
Then how would you keep track of the movements?
So I was thinking of this in the situation where there's no state whatsoever maintained on the mobile device, and instead the radius is solely going to return everything, right? But
Right, but those the drivers are moving around,
okay,
and if you're only doing the search when you modify your when you scroll,
yeah,
then how are you gonna get the movements?
right, yeah, because this would still end up being a continuous connection, a persistent connection, instead of just uh, a request response. So I guess there is still this API which says search radius or search location, but from this point, I'd say that all it does is it sets up the connection instead of you know, just getting the response immediately. So because you mentioned that we'd have a rectangle, then maybe width and
Mhm.
height is more appropriate than just a
Yep,
radius.
I think so. Yeah.
Um, these are the only real things that you get as requests the driver and rider can send out. But if we
Hmm.
have our separate response, I think maybe that's what's more useful. So over here, assuming that we have an open connection, I think you'd continuously have some array of the same thing of driver data, lat, long, right? Kind of just repeating.
Yep.
Yeah. This doesn't. Yeah, this would just be an array.
So let's see. How do we store this driver the data that the driver is sending to us?
Right. So internally, the database that I know, the database type I know this is all stored in is Uber's own custom store called schemaless. Um, but if we were to do this, would you want to just have the equivalent of all of the lat long appended to each driver? Because then how would you search, right? Unless you were to do, separate uh, indices that were to somehow be able to take in the lat long combined as data. So let's see, because all we really have is, let's say if we were to check the driver data, the main one we care about is driver UUID, right? Because we're not doing any filtering based on the make or
Hmm.
model or anything like that.
Nope.
So let's just pretend that those don't exist, and then we have this is what's going
Okay.
to ultimately be stored, right?
Right. And now how do we query this data?
Yeah,
Like when we do a search location request, how do we efficiently find all the nearby, or not
cars.
nearby, all the drivers within that those boundaries?
I guess normally when you were to if you were to try and calculate distance, you would have your lat long compared to that lat long, and maybe there's some distance function you can use, right, to determine distance. But
So
that's not
all we
really
need
a
to all we need to know if it's within these boundaries that you defined in your API, right?
yeah.
How can we do that?
Right. So the basic thing that I'm getting is there should be some. I don't know if there's a less than operator you can somehow use, even if these lat and longs were set up so that you had a secondary index on them, and you could have efficient search for specific lat and longs. Uh, I don't know if you can do some query type that says let's say that we have the user lat they provide that they're 80 and they want to be within some width which somehow modifies what the edge for their uh, lat could be. I don't know if there's a way to say that the driver's lat is less than x and it's also greater than
Yeah,
y.
most data stores don't support such an
Yeah,
index. I think there are some that do, but they're customized for geographical data.
yeah,
But assuming you don't have anything like that, plus updating an index is expensive, and we're
right,
doing a lot of updates here.
yeah.
How else can we query this data?
So okay, from what I get, we can't use the distance, right? As a
If you can compute that efficiently,
because there's no way you could search the entire set that fits within um, what is it? Some time period, right?
right?
Or
Yeah,
yeah, there's
you
no way you
probably
can
have
search
millions
from
of driver entries, and
sorry,
ideally we don't want to check each and every one of them.
right. Right. So I totally forgot one thing. When we're actually, yeah, when we're actually storing this, all of the, driver UUIDs and their lat long should be stored in some instance based on which machine they're on, right? Which quadrant they're on. So if it's a 2 by 2, 2 kilometer by 2 kilometer square, then it's pretty unlikely that you'll have, let's say even you wouldn't have that many cars, right?
Uh-huh. Okay.
There's no way you could have even 100,000 cars fitting into that, which that's a
Okay.
pretty small number. So if that's the case, what that means is that we should be able to actually grab all of the cars and then compute the distance if we chose to, right? There's no reason we should have to do any specific filtering on lat and longs there. We would
Okay.
just select all. Um,
So then, how does our storage solution look like right now?
yeah, so normally for all of these, I imagine what you'd want to have is, a bunch of Redis instances, right? And you would want to set it up such that based on your lat and long, you would go to a different instance of the machine. It's not uniformly distributed um, in the sense that, pretty much uh, all of your instances, say within New York City, are going to be hugely overwhelmed relative to something that's maybe at Yosemite Park, right?
Okay, how many instances would you have?
Thousands, right? Tens of thousands.
That's a problem.
I see. So it's a problem because of the way that we ended up splitting our data.
I mean,
So we can't just
doing
have.
how you ended up splitting the data is a good idea. I like that. The quadrant and figuring out the drivers within a block. I think that's a good idea. Having one instance per each square, per each 2 by 2 square, that's not okay.
Right. Right. Especially if you then end up having replicas, so then you have 3x that. Um, sure. So it still seems like you the idea of trying to grab all the drivers that are from one quadrant, that's still something you'd want to do, right?
Mm-hmm.
Um,
Yeah, that's legit.
so if you were to have your data in your cars uniformly set up across a bunch of Redis instances, how would you determine that a car belongs to a specific block? Uh,
Right.
if you had to go through all of the instances, that's already too much, right? Like if you had some identifier that says which block it was from, that's still too much, right? Because that means you're forced into going through all the
Mm-hmm.
Redis instances to search for all items that match a specific block.
Exactly.
So this idea doesn't really work out. It seems like whenever you distribute, these across random instances, then no matter what, you're forced into doing a search, right? Um, yeah.
Well, you can still avoid that.
Given that they're still randomly distributed around.
Mm-hmm.
Yeah, I guess it depends on how I structure my data, right? So if I were
Yep.
to have a map going from each block to each of the cars that are within the section.
Okay.
So if each instance had block to drivers,
Mm-hmm.
in that case, it's pretty instant to find all of the drivers that I care about, right?
Yep.
So if that's the case, that means I am still going through all of the instances, but I'm not doing a lot of work on each of the
Why are you
instances,
going
right?
through all of the instances?
I would need to find all of the instances that have this block as a key, right?
Maybe we can partition differently.
Um, so that you're saying if it's not just randomly uniform.
No, I'm saying, how can you partition your data such that you don't have to go through all of the instances?
Uh, well, right off the bat, I imagine there's probably some partitioning based on the, say, continent or region you're on. Uh, I'd say for this case that makes sense, right? Because all of the data that you would ever care about is always local for Uber, right? It runs over the world, but each
Okay, let's say we're tracking airplanes.
you're tracking airplanes as well. I see. Okay. Um,
So what's the reason why you have to query multiple instances?
so if I were to make it so that the partition function were to randomly use a hash on the driver UUID,
Mm-hmm.
then my blocks would be
Yep,
about uniformly distributed, right,
correct.
across the different instances, and that
So
seems to
what
be
what
the
other partitioning options do we have?
yeah. So I have the different option of the putting all of the drivers into a block, but again, we don't want to do that, right? So the all of the other ones, it seems like they're not going to be hash based. right? I'd have to use a non-hash based partitioning scheme. So there are some approaches that would say dynamically repartition, which I
So
don't think have hash
no,
based.
you're overcomplicating things. Why don't you just partition by the block?
I thought we were trying to avoid that, just
Why?
because the number of blocks you end up having, right?
But that
So
doesn't mean you have to map one block for one partition, right?
right, yeah. So if you had many blocks to partitions, yeah, I guess that would still work out. Um,
Now, next question is, what happens when a driver crosses the boundary between partitions?
Yeah, so I imagine that this is similar to what you'd want to have happen in, say, a video game, right? When you get information. So as you're crossing towards the edge, what happens is that you're able to see the next part of the loading screen, right? So I think
Mhm.
what you'd want to have is as a driver comes towards the edges, you would actually duplicate their data so that it exists across both partitions. Uh, and then, after you cross over and pass some threshold, then you'd want to remove the item from the previous partition, right?
Okay.
Yeah, so that
I think in our situation it's fine to just delete it right away. It's not a big deal if they're right on the border. I mean, our boundaries are very clearly defined right here,
right.
right? It's not like there's some fuzzy area between them. It's pretty clear where the line is.
Yeah, I guess it's not the same situation because let's say you were playing a video game, somebody could be in one quadrant and they can shoot somebody in the other quadrant, right? And you'd want
Right.
that to work. But here, if
hmm
the driver disappears for 2 seconds, it doesn't really matter.
hmm
Because they could disappear for 2 seconds, and uh, yeah, it's not a big deal, I'd say, to the user experience. Um,
Cool. Now, the other thing is, let's say from time to time, it's useful to also be able to query by driver ID, not just by block.
right.
And not just from time to time, but actually quite often. But having the data partitioned by block
I could definitely see that
doesn't really
you
allow us to find this easily.
right.
How can we fix this?
So having the data partitioned by block versus because we still don't have this block anymore, right? Now we just have drivers, just because the partitioning is already by block.
Well,
Uh,
let's get the block in there because the block is the key.
sure.
But yeah, now if I want to search for a specific driver, how do I find it efficiently?
Right. So again, it seems like if it's partitioned based on just the block,
hmm
uh, if you're trying to find a specific driver, is that based on would that be based on their driver data, so their driver UUID? Uh, Unless you were to know exactly which block the driver is on,
Which I
uh,
don't.
right, which you don't. If it's stored in this format, there isn't really a way, right? An
hmm
alternative is to maybe duplicate the data so that maybe
Okay.
you store the block mapping to the drivers as well as the
Uh-huh.
separate driver on its own. Because
Very good, yeah.
in this case, you have the block, and the only thing you really care about is the lat long, right? Like info
hmm
such as the uh, make, model, these are pretty irrelevant for the
hmm
location service, right? So if you were to have a separate set of data which were to, just map driver UUID into all of their data,
Yep.
uh, that's probably more appropriate, right?
Cool. Yeah, so a loose foreign key actually would do the trick here.
A loose foreign key.
What I mean by that is that you can have basically the block to driver association in one table and the driver data in another table.
Right.
And basically the block would reference kind of like a foreign key to the driver, but that foreign key doesn't have to be strongly enforced, right?
Right.
Like you don't need transactions. Cool. Um, Next problem is when I do search location, right? what I'm giving you is a lat long um, and the dimensions.
Yeah.
So this may cover a bunch of blocks. How do I find out exactly which blocks these are?
Right. So let's say that you are so this would be the same as almost the driver, right? Trying to send their location and determining which block they should go into. So let's say you send out your location to search.
Yeah,
Um,
let's say I do a search for starting from, let's say, 1, 1 to um, 5, let me see, 5, 3 maybe. And let's say this would cover on what we have here. This would cover something like an area that looks like this.
right. So normally, whenever you're doing a search index, the first thing that I think of is, or whenever you're doing a search, the thing I think of is a reverse index, right? But how would that apply in this situation? Because you don't. There's a huge amount of coordinates that map to this block,
Hmm.
right? To a
Right.
specific block.
Yeah, and how do you identify a block? This is also related. Like
Right.
what identifies a block and how do you go from coordinates to a specific block?
Right. So I was thinking that the blocks are just some auto incrementing number that are pre-assigned in the globe. I mean, I'm guessing in actual Uber they probably change the blocks, but let's say ours are static. Um, if if we wanted to find a block, uh, it seems I imagine there is a function that lets you uh, take, say, boundaries. Let's say the block is identified by the number, but it also has boundary coordinates, right? So let's say, yeah, for the
Well,
Swift
if we
block.
if we could do that, then our previous problem would have been already solved, right? That's the only reason we partitioned by block, is because we couldn't query those drivers by coordinates.
Right. Even if we were to do it by block, that's still probably I don't know. I guess if you're trying to find the boundary, uh, so okay, maybe I should continue with what I was trying to get at because I don't know if
Yeah.
we were thinking of the same thing. So I was thinking that you would store the boundary positions of the square, and then your lat long would do some compute to figure out whether you're within that boundary, and that if you were to do that for finding drivers near you, um, oh yeah, you would still need to even if you had the boundaries, you would still need to go through all of the blocks, right?
Yeah,
To
it's
get
it's
each
the
of the
exact same
individual
problem
blocks.
that we had
Yeah,
before.
yeah.
Let's see, if I give you a point somewhere on this grid, can you tell me which tile it belongs to
Visually,
quickly?
yes.
How?
Because I can see that it's three to the right and or two to the right and one down, right?
Perfect. So how do we translate this into a formula?
Yeah, I guess in that case it ends up being a search because you have your initial boundaries that you have, right? On let's say some 0, 0 origin position. I don't know how that applies for a sphere, but if it's a flat map, there's some point that's going to be origin,
Hmm.
and if you want to find your block,
Hmm.
you should be able to take you know the origin and the rightmost position, and then try and perform some sort of modified binary search right on this 2D plane.
That's too
Uh,
slow.
that's too slow.
Let's do something better.
Um, okay, so when I was thinking of it, and I said, you know, uh, two left or two right and one
Mm-hmm.
down.
Yeah.
The way I do that is by just seeing the position on its own. But if it were a machine and you were looking at the origin position,
Mm-hmm.
you would need to make some decision about your origin position relative to the starting position, right?
Right. So what tells you that this is one block down and two blocks left from
Right.
the from
Yeah.
zero?
I guess because it's evenly divided here, we already
Okay.
know that
Uh-huh.
based on our say lat position, we know that we are this many more fractions over, right?
Okay. So then
So
what's the formula?
yeah, so I guess in that case it ends up being the I think lat is left and right, right? So in that case it would end up
Doesn't
being
matter.
the you would look for the index at which your lat is within your width amount.
Mm-hmm. And how do
Um,
you find that index?
uh,
Oh, oh one constant time.
yeah, so sorry, I'm trying to write in here. Right, so what I ended up doing is I checked for the first block such that it's supposed to be my. So I'm assuming that I only look at one block, and this is without the overlaps. Uh,
Yeah.
it's supposed to just be the width, x times width, right?
Mm-hmm.
Equals lat.
Yep.
So I'm searching for x.
Yep.
So I have width, I have lat, so I should be able to
Yep.
determine x from that. And then y is similarly y times width equals long.
Yep. So let's put it in the formula here.
Sure. So find block is going to be assuming that it's 0, 1, 2, 3, 4, 5 is the block labeling here, then let's just say it's right times width equals lat. Right down is y times. It's kind of that.
So then how do let's extract x and y because that's what we want to know, right?
Right. So here it just ends up being the down is supposed to be something modulo whatever your
Where did the modulo
your
come
length
from?
is. Because I was thinking if this is numbered 0, 1, 2, 3, 4, 5, 6, or sorry,
Uh-huh.
like the final thing that we're looking for is 5, then you'd have to do some, in order to figure out how many to go down, you'd have to do some modulo, right?
That's if you want to label them 1, 2, 3, 4, 5, but nothing prevents you from adding another dimension in there, right?
Right.
Why not label them 0, 0, 0, 1, 0, 2,
Ah,
1, 0, 1,
right.
1, 1, 2.
Oh, okay. I see what you're actually just asking me to do. It's it's pretty much lat divided by width, right?
Mm-hmm. Right.
Yeah,
Yep.
if we were to extract.
And then since we said that these are squares, right? You can just use the constant of the square size.
Right. So that only works out for when it's one block, right? If it's multiple blocks, then let's
It
see.
still works.
Because this only finds a single block, right?
Right.
So potentially.
But if you know two opposite corners, can you find everything in between?
Oh, yeah, I guess so.
Now, of course, it only makes sense if you limit your search space to something that doesn't return millions of blocks. But cool. So let's see what else. So again, where would we store this? I
Yeah,
think you already
so
mentioned, but just to
you
go
would want
over
to
these
store,
details one more time.
yeah, you would want to store the actual data into Redis on the
Hmm.
synchronous call, but I think
Yep.
also separately you'd want to make a different asynchronous call that's going to store this in a permanent storage.
Okay.
Because a lot of this is just, well, not true. I'm thinking of this as more in the case of a ride, right? So because you have this location data always going off for
Yep.
the driver, they're doing it while they're online and while they're within a ride as well, right? So when they're just normally online, it's only Redis because it's all ephemeral. Um, yeah.
What happens if you get two requests from to send location from the same driver at the same time?
Uh, and say they're wildly different. Because if they're pretty similar, I
Hmm.
think we could just take the most recent one, right?
Okay.
Um,
Well, they're at the same time. Which one do you pick?
uh, Either of them, I would say it's if they're you know valid lat long,
Hmm.
then it doesn't really
Yep.
matter for us too much.
Correct. That's right. Yeah. Cool. Yeah, I think that's pretty much all I had. Of course, then there's the other questions like how do you scale that cluster and how do you do consistent hashing on it and how do you add replicas? But all those things are similar to what we discussed before. Uh,
Right.
so I guess you can also do that on your own. If you do you have any other questions related to this exercise?
Uh, Not that I can think of. No.
So from my feedback here, in general, it went pretty well. A few things to keep in mind is when you're doing the storage discussion, uh, you're not always limited to just one table or one object store. Like you can split that data if it makes sense. You can model it a little bit, come up with a relational model. Even if you're gonna end up deciding on using a NoSQL that you don't need the benefits of the relational data, still defining some relationships between the data, even if not enforcing them, could help in situations like this, for example. And it could even be a requirement for sometimes they'll ask you how to model the data. And it's good to start with a little bit of a denormalized solution, like don't bundle everything into a single table if there are things that can serve a separate, different purpose, you can model them separately and kind of like start with something that looks like a relational database, even if you don't end up using a relational database. It could help in modeling the data in the beginning. Um, and then another thing, I see you're always hesitant when I'm asking you to come up with formulas. It happened, I think, in a prior one of our prior sessions too. Um, I'm not sure why. I'm talking about these hashing functions here.
Right. Uh, yeah, I think there was another one like that, but I don't remember which problem.
Yeah, I think there was one instance when I asked you to compute some estimates, and then there was another hashing function that we discussed, and you kept brainstorming ideas, but never really wrote down anything concrete.
Yeah, I think I was a bit
Like
confused
this,
about the ask there.
yeah, I think so. I mean, these formulas are never going to be like complex or crazy. It's not something like you should be basically afraid of. Like it's always going to be something like some additions, multiplications, divisions, and some variables in there. Uh, when you're not expected to come up with anything crazy ever. This question, so this applies pretty well on the Uber design. Now, what I heard from Uber engineers is that they actually they implemented this using quadtrees because they also need to perform some other operations on this structure. Um, but that this one for our particular scenario here, this one works just as well. It's a valid solution, and in fact, this solution that you came up with here, you can also apply it in other commonly asked questions. Like for example, one question would be Yelp, where you're searching for restaurants that are nearby, and you're trying to filter them and get them by like by distance and recommendations. And this is an easy way basically to find those restaurants, because you limit yourself to a bunch of tiles, and then on those tiles you can even do a linear search or something, because you already reduced your search space to something manageable. I think the quad tree, the solution that Uber uses, works better for them, because that one also gives you the closest objects immediately. You don't have to actually do a pass through a tile.
Right.
But that's just a variation. Anyway, bottom line is that this idea applies to different questions that end up in the same place. You need to find objects that are nearby. You need to find restaurants that are near. You need to find restaurants are static, so it's even easier. You don't need to worry about that sendLocation. And you then basically you're partitioning by blocks. You don't need to partition by driver ID separately. So that's an easy case. But yeah, you can reuse this idea in other situations as well.
Right. So I actually had a question for, say, what the for evaluations. So I'm guessing there's different evaluation bars depending on the level you're interviewing at, right? So difference between senior versus mid and all that. How does that change things?
There is, yes, that's true. It's not as well defined as you would expect. The questions are the same always, the questions that we ask. And yes, for someone who's interviewing for a level 4 position, which is on the Google scale, it's not a senior role. It's the one right after new grad, so someone with 2 to 4 years of experience usually. You can let something slide. You don't expect them to know everything about replication or everything about every component here. They may know a lot about a certain area that they work with and have a general idea about the rest. And then for someone who's interviewing for a senior position and above, you expect them to know a lot about at least the commonly used component, and to provide decent amount of information about the rest. And you expect them to come up with the design without much help. So I think usually the line is drawn between senior versus non-senior, and anything from senior and up needs to do really well.